Polytechnic students. Today we are going to start a very important subject of engineering, WBSCT Diploma second sem course, which is engineering mechanics. Engineering mechanics is the foundation of all branches of engineering. Whether you study mechanical engineering, civil engineering, electrical engineering, or automobile engineering, mechanics is everywhere. So, what is mechanics? First of all, we should learn that. What is mechanics? Mechanics is the branch of science which deals with the study of force or forces and their effects on bodies. Forces and their effects on bodies. In simple words, mechanics studies how and why objects move or remain at rest. How and why objects or bodies or particles, objects move or remain at rest. So this is what is mechanics. Now, what is engineering mechanics? Mechanics is a theoretical subject, and when the principles of mechanics, principles of this theory are applied to solve engineering problems, it is called engineering mechanics. So, when theory of mechanics are applied to solve engineering problems, then we call that engineering mechanics. It becomes engineering mechanics. So engineering mechanics is nothing but applied mechanics, application of mechanics in to solve engineering problems. Okay. For example, when a civil engineer design a bridge, when a civil engineer designs a bridge, he must calculate how much load the bridge can carry, and what forces act on the bridge. This is engineering mechanics. Okay. Now there are two main branches of engineering mechanics. Engineering mechanics has two main parts. One is called statics and another is called dynamics. As the name implies, statics deals with bodies at rest. Bodies at rest. Like this smartphone on which you are watching. A smartphone, probably it's on some sort of stand you are using. And my tablet is also static, where I am writing this, but the pen by which I am writing is not static. It is moving over the surface of the tablet. Likewise, any book lying on your table, you observe any building standing on ground, your college building. Here, the body is not moving. The body is not moving. And then The branch of engineering mechanics which deals with those bodies are called statics. On the other hand, dynamics. The dynamics deals with bodies in motion. Bodies in motion. Example, a moving car, this moving pen, rotating fan over your head. Okay, so these are called dynamics. Dynamics has two parts. Okay, then we can divide dynamics on two parts. Dynamics can be divided into two parts. One is called kinematics. Kinematics. Okay, and another is called kinetics. We are familiar with this term, kinetics. Kinetics, but not familiar with this term, kinematics. What is kinematics? Kinematics is study of motion without force. Without force, if we study the motion of any object without force, we can call it kinematics. Without force. And if we are studying the motion of any body, any particle or object with force, we are actually studying kinetics of that object or body or particle. So without force, kinematic study, and with force, considering force, kinetic study. Not considering force, when we are not considering any force, then it is just kinematics. So kinematics and kinetics are two branches of dynamics. Okay, now we are using the term force here and there, without force, with force. So what is force? Force is the most important concept in engineering mechanics. Force. 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 What is force? Is simply force is a push or pull acting on a body. Push or pull acting on a body. You push an object or you pull that table, pushing the door, pulling a rope. These are examples of force. So force can move a body. Force can move a body. Force can stop a body. Force can change direction. And force also can change shape. Shape of object. Okay. So force can do all these. Force can do all these. Move a body, stop a body, change direction, or change shape. Now force has four important features or characteristics. Features or characteristics. Four speciality of force, we can say. Number one, force should have a magnitude. Magnitude. Number two, force should have a direction. Number three, force should have a line of action. Line of action. And number four, force should have point of application. point of application. Now, when we are talking about these four important characteristics of force: magnitude, direction, line of action, point of application, we can recall that the physical quantities which have both magnitude and direction are called vector quantities, and the physical quantities which have only magnitude and no direction is specified, those physical quantities are considered as scalar quantities. So we know that in our um, 10th or 9th class, we have studied what is scalar quantity, what is vector quantity, and there we have seen that force is a vector quantity. Force is a vector quantity. So the question arises about the magnitude and direction of force. So this much we can understand. Then the third point is line of action. What is that? Line of action of force. Force should have a line of action. This comes when we are considering the application of force on some object, which can move that object, stop that object, change direction, change the shape of any object. So to do these all things, force should have a line of action. Each force should have a line of action. There may be more than one kind of force, and there may be combined force operating on an object. Then each force should have some specific line of action and point of application on that object. And point of application on that object. Suppose we are moving this block or moving this stone block from left to right. You are moving this block from left to right. So to do this, you have to apply some force, and that force will be applied through some line. This is the line of application. This is the line of application, okay? And that applied force should react on some point of that body. This is the point of application. So this is the point of application, and this is the line of application, line of action. Okay, clear? Now we are returning to uh, the force unit of force. We all know that SI unit is the international unit. So what is the SI unit of force? That is Newton, named after a famous scientist, famous physicist Isaac Newton. It is Newton, and the symbol is capital N. Remember, not N full stop, just capital N. This is named after scientist Isaac Newton. Okay. Now, one more important point which I should have mentioned first, that is the definition of body. What is a body? We are saying that there is body, acting on a body, move a body, stop a body, change the direction of a body, change shape. So what is body? In engineering mechanics, the body means an object, any object. Body means any object. Body means any object. Understand that body means any object. It can be car, it can be table, it can be bridge, it can be any particle. Okay, it can be any particle. So what is a particle? Then what is a particle? Particle means a body with negligible size. A body with negligible size. Example, a small ball can be treated as a particle. But a football can be treated as a body. A ping pong ball can be treated as a particle. A grain of a sand can be treated as a particle. Okay, so it's simple. When we are using these terms in future, there should be no ambiguity. What is a body or what is a particle? Okay. Now, engineering mechanics is everywhere. For example, when you ride a bike, you push a table, you lift a bag, you are using mechanics. So the question appears in our mind that why study engineering mechanics? Engineering mechanics helps engineer to design machine, design machine. Number two, construct buildings, construct buildings. Number three, to build bridges. Number four, design vehicle, design vehicle. So without mechanics, engineering is impossible. You see. Okay. So today we learned about the basic concepts of mechanics. What is an object? Theory of mechanics. Difference between mechanics and engineering mechanics. The two main branches of engineering mechanics, statics and dynamics. And what is the meaning of these terms? Dynamics can be further divided into kinematics and kinetics. What are those? Okay. What is a force? Simple definition, force is a push or pull acting on a body. What force can do? Move a body, stop a body, change direction, change shape, etc. And four important features of force: magnitude, direction, line of action, point of application. Unit of force, SI unit. I should have mentioned it, SI unit. Difference between body and particle. And finally, application of engineering mechanics. Some example: design machine, construct building, etc. So that's all for today. In our next class, we shall discuss vectors as is used in engineering mechanics. Vectors in engineering mechanics, vector algebra, some basic rules, etc.